Okay, we're recording. Anybody got any questions? Yes. Yeah, I like the recording. Sometimes I forget what I promised to do or what I said. Uh, and sometimes it's good to go back and review stuff, make sure we covered things so that I can not have to repeat them next time. But do you have any questions on the assignments coming up or what's due or anything else? If not, we'll just sit here for a moment and then give people another moment or two, minute or two to come in, and then we will get started. Hopefully, we'll have a couple more people. Otherwise, I'll just be talking to you two, which isn't bad, but it'd be nice to have. It's easier to have a class discussion if you have a class full of people. Yeah, on the extra credit, what I think I'm going to do a deal. I'm going to offer people the opportunity to redo one of their assignments. Okay. Some people got the idea or got mixed up on instructions or maybe didn't follow the instructions or whatever. So I'm going to give everybody the opportunity to redo one of their assignments for 5 points. And so everything will be worth half. And I think that way everybody has the opportunity. If you don't want to redo it, I mean, some people, feel I don't want to bother. I've got other things I've got to deal with that are more important. So I think what we'll do is I'm going to call it Project Redo, and everybody gets to do one assignment. Even if they did great on it, they want to do it even a little better. If somebody got, I don't know, I think I have one or two people along the way who maybe got 9s or something, and I would say, I think I might offer the people who did really well the opportunity to say, hey, can I just get the extra credit for this, and whatever their score was on that, I'll cut it in half and give it to them, rather than grade a bunch of excellent papers trying to give them a little bit more excellent. So for some people, it might be an easy, 4+ points because they got a real good grade, and they say, why don't you just redo whatever? But the people who maybe just, because some people really just didn't do well on assignments here and there. So I'm going to do that Project Redo and let people redo their assignment. Let me back up here on the chat box and see what someone's saying. Oh, okay. Yeah, on your question, Lucy, about pre and post test,
Yeah.
that is one of the more uh, frequently used tests because it shows what they know ahead of time, and it shows you what they know afterwards, and it allows you to see not only the improvement, but if you have different groups, you have your treatment group and your control group, then it allows you to see which group did better, and then there's different tests you can use to normalize the thing. So say group A, the control group started out a whole lot worse. Maybe the kids weren't as knowledgeable about the subject, and maybe they improved, but they didn't have as high a score as group B, who started out higher and ended up higher. You can still show using things like range and standard deviation and mean and stuff. You can show how maybe the improvement for the lower group was actually more significant, even though their averages and their test scores were still lower than group A, than the first group. So, there's oodles of ways of doing it. Again, pre-test, post-test is one of the more popular simply because it allows you to do a lot without a whole lot of unconventional type of instruments and things like that.
Yeah, I guess, can you hear me okay?
I can hear you great.
Okay, so my research, I was thinking about MOOC course design versus multiple intelligences. So I was thinking of course, I was thinking about doing like more like a qualitative survey.
Right.
But then I thought, well, wouldn't it be interesting to present a MOOC course and without any redesign, and then study the population to see which multiple intelligences they possess, and then find a similar group to take the same course, but then redesign the course to reach the different types of multiple intelligences and see if there is any increase in retention rates in the course.
In the
and
redesign.
so that
Yeah,
so
that would be good.
that could determine if course design that reaches a wider variety of multiple intelligences produces more ability for students to feel like they can remain in the course and complete it.
Right. No, that would be good. I think that would be real
Okay.
good. And I'm looking at Adil's question here. I'm sorry, did you have another question? Okay, looking at Adil's question here, he asks, what if we do a new assignment for that credit? Yeah, I should have mentioned that. I want you to use a different article. Okay, use the same one of the criteria, either assignment 1, assignment 2, or assignment 3. Make it let me make that. Let's see, not meta-analysis. Okay, it'll be, yeah, I want you to use a different article. I do not want it to be a meta-analysis. A meta-analysis is when you do like a literature review to see trends and stuff. I want it to be on a unique individual study. So thank you for that question, Deal, because I probably would have forgotten to conclude that in the instructions. Somebody would have gotten it wrong. I'd have gotten unhappy. They'd have gotten a low grade, and then I would have said, see, this is what happens when I give extra credit. I don't give good instruction. Okay, so no, that's real good. Deal. Okay, there we go. So I think we have a Deal. We have Karen, we have Lucy. So maybe some people will join us. Why don't we get started rather than wait too much longer, because I have 7:07, so we've already given enough people. I think whoever's going to show is here, and why don't we move forward? Because there's only a few of you, I won't pepper you with questions like I would normally do if we had a whole class, unless all 3 of you manage to read everything and can answer. But I will ask you questions. If you don't answer them, that's fine, because this is supposed to help you retain things. And again, with a small group, if we had, 9 or 10 people, the chances of somebody coming up with the answer is a lot greater than when you have 3. So don't be embarrassed if you don't know the answer, or if you're just guessing at the answer. Something sounds vaguely familiar, but you're not sure. Again, we're here to reinforce and to learn, not to prove that everything is perfect and, the course was written so well that everybody picked up everything on the first pass. So as I was asking Adil and Lucy, Kara, you just got in here. Earbro, so I have no mic. Okay. I have earbuds all over the place. I should have sent you them. Yeah, what you could do is just is kill your mic unless you have something specific to say, then turn it on and maybe turn your earbud volume down. That or just write short questions, whatever. You'll figure something out, I'm sure. Anyway, when we get on here, this module was kind of crazy because it involved both quantitative and qualitative stuff. He starts off with heavy qualitative and then just jumps back to quantitative, and a lot of it was more on quantitative, more than I would have expected or maybe even desired. A lot of the readings did not come from the Salkind book, either whatever version you might have, and a lot of it came from the handy stats, which maybe some of you have, maybe none of you have. So a lot of what I'm going to review tonight I pulled out of the handy stats book simply because I figured a lot of people in the class, didn't have it, and so seeing how a lot of the module was based on that, I figured I better cover it just to make sure people know what I'm talking about, or what the quiz is asking, or things like that. A couple of different things here. First of all, seeing how it starts off with quantitative stuff. I guess I need to get that first. Let's see. Okay, how would you define qualitative research? Anybody? And feel free to speak out or text or whatever. Okay, that's cool. Okay, basically qualitative. Well, as I said, it's a lot easier when you have 9 people. Sometimes people are fighting to answer. And instead with 3, it'd be nice if you could answer some of these questions, but if not, that's just the way it is, I guess.
I would always tell my kids in math, I'd always tell them to kind of think about like quality versus quantity. Like quantitative is something measurable, and then like the qualitative was more like a quality about something. And I know that's an oversimplified version, but that it was more quantitative. It has to do with values, specific values.
Exactly.
Qualitative is like characteristics.
Yeah, that's what I basically do the same thing. I say when you're talking about quantitative, it's quantity. You can count it, you can observe it, you can measure it. Okay, and there's different ways of counting and measuring and observing. And in qualitative, you're dealing with qualities. You're dealing with not necessarily quality like high quality or low quality, but qualities as is talking about features. You're talking about attitudes. You're talking opinions. You're talking about beliefs. You're talking about things you can't necessarily count. Although in many cases we do use numbers to try to 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 uh, to demonstrate and display that information. But no, Kara, that's basically right. It's what you can count and observe, which is versus what you feel and can't count or observe. And sometimes oversimplifications work best simply because they allow people to grasp the concept, and hopefully they'll be able to carry that into more complex contexts. Okay, qualitative research does several things. It's a type of scientific research, and it does several different things here. Like quantitative research, it seeks to answer a question. Quantitative research has research questions, both, and qualitative has research questions. Sometimes quantitative research will state things in terms of a hypothesis rather than a question. You don't see too many hypotheses in qualitative research. Another thing, it uses, like quantitative research, it uses a predefined types of sets of procedures. Now, of course, the procedures for qualitative and quantitative are different, but they're still spelled out. You have different types of instruments in quantitative. You have different types of research designs in qualitative. Another thing, it collects evidence. Again, both forms of research do this. But where they sort of separate is in the findings that they find, that they come up with. In quantitative research, as I said, you have hypotheses, you have research questions, but with hypotheses, you're stating this is what we think is going to happen. Okay? In qualitative research, you don't know what's going to happen, and we'll look at some possibilities or some types of qualitative research where you don't even start thinking about coming up with findings or coming up with a research question until you've looked at what's happening and saying, okay, let's build a question around this. That's what's referred to as grounded theory, and we'll talk about that in a few minutes here. Okay, and also in qualitative research, it produces findings that are applicable beyond the immediate boundaries of the study. And again, this is very, very similar, but not the same as quantitative research. In qualitative research, we talk about the findings being transferable. Okay, can you possibly relate this to the general population or to another group? Okay, in quantitative research, we talk about being reliable. Can this be repeated? Can you do it again with a different group? So qualitative research and quantitative research, they have some basic commonalities, but there are also a few things. Again, the uncertain findings and the way the exact procedures that are used that make them different. And so it goes on. Okay, so in looking at some of the differences between quantitative and qualitative research, and I don't know how well I can see this pretty well, but I'm assuming you guys can too. If not, I will post it. I will post this table just because I think it's a neat little table, and I'll make a note to post that as a separate document. Or if you want, you can go back and look at it here. And here's just some of the differences. Basically, quantitative and qualitative research methods differ in their objectives, their analytical objectives, the type of questions they ask, the types of data they collect, the forms of data they produce, and the degree of flexibility built into the study design. Generally, quantitative methods are fairly inflexible. Okay, they use surveys and questionnaires, and they ask participants identical questions all in the same order. Whereas in a qualitative type of study, you'll have very often you'll have interviews or surveys, but you'll have what's called a semi-structured interview. Okay, I have maybe a set of predetermined questions I want to make sure I cover, but based on your answers, that could generate more questions. So that's why they call it semi-structured. You have a basic framework, but then that could go off anywhere depending on where the people, how the people respond. And so there's a whole lot of flexibility in some forms of qualitative research. Where quantitative, it's pretty much bam, bam, bam. You're walking people down this survey, and there's not a whole lot of flexibility to it. Because of that lack of flexibility, it requires the researchers to come up with a thorough understanding of the important questions to ask, because you're not going to be able to, okay, we're going to add on to the survey and send it out, and you got to fill out those last 3 questions. That doesn't happen in a semi-structured interview. You can wing it. Somebody says something that you hadn't heard before, so you can ask follow-up questions to that, and you can go meander all over the place based on what that person's responses are to the earlier question. So again, qualitative is can be very flexible. Quantitative tends to be not very flexible. Okay. Moving on to a few things. Let's look at some of the different types of qualitative studies we can deal with. One of the ones that you'll run into, and I want to say easiest to do, not because the simple format of it is easy. It's easy because you very often you do not need to do an institutional review board, and that makes life a whole lot easier when you're doing a study. Anybody have an idea? Oh, excuse me. Anybody have an idea of what we're talking about when we talk about a biographical study?
Well, it's like biography, like describing, this kind of like describing the story per se.
Yeah, basically you're focused on one person, but the important thing about biographical studies is rather than, say interviewing somebody, which would be it could be case studies or something like that. That would be another form of gathering biographical information. But in a biographical study, what you're looking at is archived documents. It could be books that other people have written, reports that other people have written, movies, videos, things like that. Now, I said it's easier because you don't have to mess with the IRB. It's harder because depending on your subject, there may be oodles and oodles, lots and lots of information, lots of articles. If you were to write, do a biographical study on one of the U.S. presidents, dozens, if not hundreds of books have been written about past presidents. Lots of articles. There's tons of pictures. There's lots of movies. There's all types of things. And if you were to do what is a truly exhaustive study, a biographical study, you'd go through all of this. It's very similar. It's much like a literature review. Okay. In that you're trying to exhaust all the possibilities of describing what is known about this individual. Alrighty. And, so it used, you can use interviews, you can use their own speeches, their own writings, or writings by other people, different media. You can just any source you can find that already exists, you would make use of, and so it can be very exhaustive. Okay, here's a bit on that if you want to read all the particulars of it. I think I just went over most of that. So again, you're using documents. You're trying to exhaust all the resources you have to put together a very detailed picture of who you are studying, or maybe the group you're studying. Moving on, and next is the interview, and you're probably all familiar with interviews. You've all been on them either to get a job or doing some group is doing research someplace. But in research, interviews have a very specific purpose. And what kind of information do we gather through interviews for research purposes? Anybody?
Like opinions, attitudes, feelings about something.
Yeah. In a way, it's very similar to a job interview, but you hit it right on the head, Lucy. They're designed to generate participant perspectives, okay? Like you said, opinions, attitudes. Maybe you have them relate their experiences. If maybe you're talking to veterans with post-traumatic stress syndrome, and so you want to, they're talking about their experiences. And qualitative researchers will take what the information they get and make inferences based on these perspectives. So it's extremely important to get as much data as possible. That's why I remember when I talked about the semi-structured interviews, how you have maybe some set of basic questions you want to cover, and then you'll add questions as you go along, depending on what the person says, just because you want to continue that conversation and get as much detailed information. And so they'll start out with some carefully designed interview questions to provide specific and detailed data for later analysis, but then the subsequent questions, sort of the spontaneous questions, will add to that. Okay. I just asked that. Okay. Okay. What do you think, would you say would be the big difference between interviews and surveys? And we sort of covered this already, but maybe you want to talk a little bit more about that. Anybody? Well, there. Let me answer my own question. Go ahead.
I was going to say, like, an interview, it's more like holding a conversation, and then based on the feedback of the person, you could generate more questions. But a survey, it's very structured. You just answer the questions. Although there are surveys where they allow you to give your own opinion or add to whatever's being investigated, kind of.
Yeah, no, that's pretty much it. Like you said, in surveys, the researchers ask the participants the questions, and like I said, sometimes they'll have an open-ended question, but again, they can't go beyond that. If what somebody writes in that little box, 2 or 3 sentences in a little box expressing their opinions or experience, and you look at that later and say, it's really interesting. I wish I could talk to that person and find out, what they meant by this or what. In an interview, you can do that. Well, what do you mean by that? Or how did you feel about that? But you can't do that again in a survey. And again, it's the inflexibility of the survey, the quantitative instrument versus the flexibility of the qualitative interview. Alrighty, moving right along. Oops. Phenomenology. This is a little bit different type of study. You see some of this mentioned in some of the articles you might come across, but it's probably not as popular as some of the other research designs. Anybody want to make a stab at phenomenology? Okay, let me do that. I don't know. This is a little bit more off the wall. You don't run into this as much. In phenomenology, that too. Phenomenology in phenomenological studies. Phenomenological. There you go. Phenomenological studies. Easy for me to say. They refer to it's a way of looking at a phenomena, an experience from the individual's point of view. Now, all these qualitative designs sort of place more emphasis on the individual perspective, but here you're going in depth to get their experiences. Okay, so you're looking for their reactions and perceptions and feelings. It could be of an individual. It could be of a group of people. Okay, and how they experience an event. And this is of primary importance to the phenomenologists, as they call them. They're looking to understand an event beyond the purely quantitative details. You could talk about the bombing of Hiroshima at the end of World War II, and you could say, okay, 200,000 people died. There was lots of destruction, blah blah blah, and you get a picture of what happened to that city. But then you started interviewing the people who survived, and you get a more detailed picture of what happened to that city. And so that would be like a phenomenological study. If you get down and talk to the people about a specific incident and how people perceive that and what they experienced in the middle of that. Okay? And okay, well, here's a little bit more explanation about it. When you talk about phenomena, you talk about an occurrence or experience, a logical means to understand it. So it's just a way of looking at people's point of view, focusing on a certain experience, a certain event. What was your experience? What was your recollection of the day John F. Kennedy was shot? Well, for a lot of you, you probably don't remember because you weren't born yet. But for me, I remember. And so, or you know, when 9/11 or Pearl Harbor or any major big event like that, everybody has, you know, they remember what they were doing when they heard about whatever the event was. And so that would be a phenomenology. Okay, grounded theory. This is the weird little research design I was telling you about, because it sort of almost runs backwards. You have a basic idea of what you're doing. And, oh, well, let me ask you: is anybody familiar with grounded theory and how it proceeds? Okay, well here, let me tell you. Okay, when you're dealing with grounded theory type stuff, as I said, you're kind of starting backwards, and maybe that's not the best way to put it, but that's the way I'm going to put it. I said you're kind of starting backwards, and what you'll be doing is coming up with some basic criteria. Okay, you have interpretations that are basically taken from raw data. You observe things, you maybe ask questions, things like that. And basically, as you ask you have a certain subject, a certain topic you're dealing with. You don't necessarily say, I'm trying to prove this or I'm trying to find out this. You just want to say, study. Maybe you have a new curriculum in math for 7th graders or for, say, college freshmen. You want to see how effective that is. Okay, so say we're going to study the opinions of these college freshmen on this new curriculum. So basically, what you're going to be doing is getting their interpretations and looking at what emerges. They'll start saying, well, you know, I really like the text, but the tests are really hard, and maybe a sizable number of the students echo those same sentiments. The text is good, the tests are hard. Maybe there's other things. I don't understand the videos. The other theme, different points come out in these interviews and in these data collection efforts. And the researchers often begin with a broad topic. As I said, what is the effect of this new curriculum on math curriculum on freshmen in college? And they'll use qualitative methods to gather the information. Again, we've talked about, you know, interviews. We've talked about doing case studies. We've talked about phenomenology. We gather information in different ways, and we'll use this information to define or maybe further understand a research question. So maybe you'll say at the end of all this, you'll say, well, the way to present this course, we believe, is to not use the videos and focus more on the text. Okay, grounded theory. Remember when we were talking about qualitative and quantitative theory, we were talking about qualitative design being theory development, and quantitative design being theory proving. Okay, so here you're developing your theory. So you gather your information, look what the information tells you, and say, okay, based on what we've gathered, this is what we think happens in these situations. So I said, you're sort of putting the cart before the horse. You're gathering the information and developing themes and comparing different people's comments. And so you're coming and saying, okay, what gets mentioned a lot? You know, you have 10 people and 8 of them like A, and 7 of them hate B, and 5 of them don't even remember C. Okay, and so you start developing different themes. You start noticing different patterns in people's responses. Then you develop a theory based on that. Okay, have I totally confused it? Because it's kind of a nebulous thing, because people say, well, you can do what you want. Well, you can't really, because you have to pay careful attention to what's being said. And you'll hear a lot of times in qualitative research, especially if you talk about discourse analysis or content analysis, they'll do coding and they'll look at themes, what people say, and they'll code things so that different themes, different ideas, different concepts, different likes and dislikes, different perceptions, different attitudes, all are given like a numerical definition. And then people will develop data based on these. A grounded theory begins by interviewing subjects and perhaps asking them to write down their thoughts. Okay, in a grounded theory study, the researcher would then develop themes from reading the text. They'll record they'll record people's interviews if it's a verbal interview, and then they'll transcribe it into written text so they can examine it a little bit more clearly. Okay, so this said they'll read the text by using specific examples of where respondents mention common things, which may then become a topic for further analysis. The study is dynamic. It can constantly be changing. You might start out thinking, we're going to talk about what the freshmen think about this math curriculum. And it might go off in a totally different direction. You might find the major emphasis is not so much on that particular curriculum, but on how it was delivered in a more general sense. So, as I said, the study is dynamic. It can be continually revised throughout nearly all phases of the study. And the perspective is centrally important. The respondents' perspectives are centrally important to the qualitative measures. In a grounded theory study, the end result is to generate some broad themes. And the researcher is not attempting to generalize the study in the same way you might do in other types of qualitative or in all types of quantitative data. So it's a little different, and here's some of the things I just talked about here. You're basically continually deriving new stuff. The story emerges from what you collect. You start off with a broad topic and then try to get more information on it. So that's grounded theory. As I said, some people say, you're a lot easier, but really it's one of the toughest things you can do, because the concept sounds simple. You just ask people questions and come up with an idea, but it's that coding thing. It's sort of dissecting all the text. And if you have, I know one student did a dissertation based on using grounded theory, but had close to 100 interviews. So you imagine taking 100 interviews, conducting 100 interviews, transcribing them, and you can get, software that'll transcribe it, but then you have to go through all that stuff and pull out themes and common ideas and common perceptions from all these people. It's a very painstaking process, but it is also a lot of fun and very interesting. Finally, there's ethnography. Anybody know what an ethnography is? Going once, going twice.
Ethno as in groups, race.
Yeah.
Groups.
Well, it's not necessarily group. Just to stay with groups. It's not necessarily ethnic, although a lot of studies deal with ethnic. A lot of ethnographies deal with different types of ethnic groups. It's really any type of groups at all. It focuses all basically on any type of group, and that could be a large or small population, and it reveals a lot of direct observation out in the field. A lot of times you'll see if researchers are going to remote areas or third world countries, they'll actually live in the culture, become part of the culture, and this of course can introduce some bias. You have a researcher who's in the middle of the Amazon or somewhere remote place, and he pulls out a lighter and lights his pipe. Well, these people have never seen fire sticks before, so I mean that could change the whole concept. All of a sudden they're worshiping this researcher as a god, and all he wanted to do is just observe people. And so one of the things with ethnography is that researchers can introduce a lot of bias, and so they have to be very careful even though they're within the culture, to be as transparent as possible. And so what they're trying to do is present a picture of the culture through the eyes of the people in that culture. And I don't know if any of you have ever heard of Jane Goodall. She spent years in Africa living amongst chimpanzees and apes and studying them. And she, after a while, was considered part of the group, So ethnographies don't necessarily even have to deal with humans. And so again, you're looking at looking at the cultural perspectives and gathering information based on a specific culture, whether it's a culture based on remoteness, based on being chimpanzees rather than humans, culture, maybe a religious culture, stuff like that. But studying that specific group with an eye of representing the data through their perspective, through their eyes. Okay, that was the last one. The last one is case studies, and you probably have heard of these before. Anybody want to take a stab on case studies and how they're presented or conducted, I should say? Now let's move on. Let's just check it out here. Hey, case studies are an in-depth analyses of people and relationships, and there's usually some basic unifying event. Sometimes these are called ethnographic case studies when you're dealing with a specific group of people. But they don't have to be people focused. They give an example here how a case study look at a program might be conducted to see how it accomplishes an intended outcome. Or you might have like a Department of Education might conduct a case study on a curricular implementation in a school district, examining how the new curriculum moves from development to implementation to outcomes at each level of interaction. The instructional designer, the developers, the school leadership, the teachers, the students, maybe even the parents. So a case study is, as I said, pretty much an in-depth analysis of a situation. Okay. Moving on here. Going on. Before you can do any type of study, you have to. Well, I can't say before you can do any type of study. Before you can do most studies, you have to have people. And in order to get people, you've got to find them. And in order to find them, you have to do what's called sampling. Basically, what sampling is you're trying to get a group of people that represents the population that you're interested in. And there are several different ways of doing this. All of them are very similar, and some of them are grouped under this broad heading of purposive sampling. Anybody familiar with purposive sampling? Okay, it's one of your more common strategies. It groups participants according to, say, some pre-selected criteria to a popular research question. If you were going to study what, say, master's students think of online courses, what kind of people would you go to do your subject, to be your subject? You go to master's students who are taking online courses. You wouldn't go to seventh graders. You wouldn't go to people who are just doing face-to-face courses because you wouldn't get the information you want. So you are purposely selecting a group of people based on criteria to get the answers you're looking for. You're not necessarily wanting to get the results you're looking for, because that would be bias. You don't want to find a bunch of people who say, I want to find if most people, are in favor of President Trump's policies. And you go to the, President Trump's headquarters and ask those people. That'd probably not be a very objective survey. At the same time, if you went to the Democratic Party, that would probably not be a very objective survey either. So, process sampling is you want to make sure that the group you're taking in for your study represents that class of people. Again, college students who are taking online courses or whatever. Okay, and so it's one of the most common sampling strategies. And sample sizes may or may not be fixed prior to data collection. You usually want to estimate how many people you need, but sometimes that grows. Sometimes you get a huge response that you weren't expecting. Sample sizes are often determined on the basis of what's called a theoretical saturation point. This is the point where it doesn't matter how many more people you get to take your survey or answer your questions or whatever, the data is not going to change that much. You're not going to get that much more information that will affect your outcome. Okay, purposive sampling is mostly successful when data review and analysis are done in conjunction with data collection. So you're sort of reviewing things as you go. Sometimes you might have to make adjustments to your survey or to your questions or to how you're analyzing the data. And you don't want to collect all your data and find out, this is all wrong. It's okay to make some little changes here and there. Then you have quota sampling. Anybody familiar with quota sampling? Okay. Anyway, quota sampling is also a type of purposive sampling, and again, it's very common. In quota sampling, we decide while designing a study how many people with which characteristics to include as participants. The book I was reading, or the article I was reading rather, was talking about using the criteria of how many people were infected with HIV in this given population in a third world country. And under quota sampling, the population they were looking at, the area, the city they were looking at, had a certain percentage of men to women who were HIV positive. So they want their sample to have that same percentage in order to reflect the general population. So that's what's called quota sampling. Again, you're looking for people with specific characteristics or in a specific situation, but here you're trying to keep a quota, a ratio that reflects the general population. And that's quota sampling. And I mentioned how they're different just a moment ago. Basically, quota sampling is a lot more specific. You're setting up some standards as far as the numbers of types of people you want to have. You don't know what their responses are going to be. You're just, again, trying to mirror the general population. Finally, there's a thing called snowball sampling. And again, this is another form of purposive sampling. Maybe it's purposive, I don't know. I say purposive. Anyway, snowball sampling. Okay, I interview you. And at the end of the interview, I say, would you have somebody else that maybe would fit into this category that maybe I could interview? And they say, oh yeah, my friend Joe. Or maybe they get on Facebook and say, hey, this guy's doing this interview on college students who are taking online math courses. Anybody want to participate? Whatever their social network is, they communicate to other people and lead the researchers on to a larger sample, more people. Basic quota sampling, as I said, is considered a type of purposive sampling. It's also very common. In looking at the different types of samples, again, all these have similarities. Some of them have specific differences. One of the big things is you're trying to gain a population or a sample, a group of subjects that reflect the population or the scenario you want to project, that you want to test. You want to be able to generalize, or not generalize, transfer to a larger population. So if you're talking about college students taking online courses, you're going to look for college students taking online courses. You don't necessarily want to bend it one way or another. College students, who have A+ averages who are taking online courses to see if online courses are successful. You just want to get a general idea. Have I lost anybody yet? Have I lost everybody yet? Everybody
Nope, I'm good.
Okay. Okay, moving right along. We're going to jump back here to quantitative research. Now, as I said, spent a lot of the reading and stuff, or the stuff listed in the module dealt with quantitative research. And I want to be sure to touch base on that. In some cases I used, in fact, some cases, almost all cases I used different resources so you get a different perspective that maybe restated what you were reading in the assignments. Talk about probability. What is probability? Anybody?
The likelihood that something will occur.
Yeah, it's basically the likelihood that an outcome will occur. And in this case, when they're talking statistics, they're talking the outcome, the likelihood that an outcome will occur by chance. Okay, and that sounds maybe negative, the exact opposite of what it should be, but we'll talk about that in just a moment, why that is a good definition. Now, there are three components to probability, and one of those is relative frequency, another is random sampling, and the final one is statistical significance. Now, when you're talking about relative frequency, you're talking about the frequency for which a value relative to the frequency occurrence relative to the total number of subjects. Okay, let me bounce through here so we can get it. Okay, here we go. Here's a table, and a lot of times you'll see these frequencies expressed in different ways. Word of warning. When you are writing a journal article or you're writing for me, when you see it has an out of statement, okay, again, any numbers less than 10, meaning 1 through 9, you spell out. Any numbers 10 and above, you can use the number. And I know it looks weird when you read a sentence and says 1 out of 20 and 1 is spelled O-N-E out of 20, which is 20. It looks funny, and maybe your 8th grade English teacher would jump up and down and scream at you. But for journal articles and the way things are written under the American Psychological Association, That's the way you do it. So it wouldn't be 1 out of 20. It'd be ONE out of 20. TWO out of 20. FOUR out of 20. Okay? Okay, I've harped up on that enough. I think you might get the idea. So anyway, relative frequency is the frequency for a value relative to the total number of subjects. Alrighty? Moving right along. Random sampling. Anybody have an idea what that's all about? Uh-oh, somebody's calling somewhere, but they're not calling me. I'm not answering. Okay, random sampling. Okay, basically that's a procedure that ensures. Let's wait for that. That's not my phone. I don't know where that's coming from. Anyway, hopefully you can hear. Can you all hear me still, or should I wait for that phone to stop ringing or whatever it is?
Yeah, we can hear you.
Okay, good. And whatever it is, it stopped. So I guess it doesn't matter. Okay, random sampling. Okay, that's a procedure that ensures each individual in the group has an equal chance of being included in the sample. Okay, so if you were trying to get a group of people, you just randomly assign them. You say you pick, okay, all the odd people in group A, all the even people in group B. You don't go through and say, okay, who's getting A's? Let's put them in the first group, and who's getting C's and put them in the other group. Okay, it's random. You don't set up any criteria. They're just placed in a group, and they have an equal chance of being included. Alrighty. What is that too? What is statistical significance, and how is it expressed? Okay, anybody want to take a stab at what statistical significance is? All right, I'll take a stab at it because I got my notes. Okay, statistical significance simply means that you're very sure that the statistic is reliable. It tells you how sure you are that a difference or a relationship exists, and that the findings you have are not due to chance. Now, the significance level for a study is chosen before the data collection, and in statistics, you see a lot of times, and I should have made a little thing here to show to you, you'll see where it says what they refer to as P at the 0.5 level. It'll be a P equals, and then the lesser or equal sign in 0.5, and I'll send that out to you. I'll make a note. So it's called P at the 0.5 level. That means the chances are 5 out of 100, or 5%, that this occurred by chance, by random things that your treatment had no effect. It's just something happened, and your treatment was not the cause of this difference, this change, this improvement, this whatever. So called P at the 0.5 level, and basically statistically significant if that reliability is less than 0.05, is less than 5%, however you want to call it, then you can say that the findings are statistically significant. Oops, let's see, somebody said something here. Let me check the chat. Okay. I want to make sure I wasn't missing somebody's comments here. Okay, any questions about statistical significance? And we will move right on here. Okay, we talked about statistical significance, and let me go one more here. Next. Okay, variance. Now, what is variance? Anybody? Okay, let me go with that.
Is that how? Oh, okay.
Oh, go ahead, Lucy.
Is that how variance, like how the numbers are further away from the mean? I probably got it totally wrong.
No, you got it right, nailed on the head. How far away they are from the mean? Okay, mean being the average, and sometimes in some studies they'll have an expected value. They'll state, we think it's going to be here. The average scores for the students in this test is going to be 85. In other cases, they just take the test. They take all the students, add up their scores, divide it by the number of students, and get a mean. But no, you're exactly right. It's basically variance. It measures how the data distributes itself about the mean, or in some cases, an expected value. Now, do you remember what range is? Anybody?
Range is The lowest to the high, the difference between the lowest and the highest value.
That's right. It shows how varied. Now you might only have one score at say 65, and you might only have one at 95, and all the rest of them are at 80, which is right in the middle. Doesn't matter. The range is the same. Or all those other scores could be 65, 75, 85, 95, or 65, 66. It doesn't matter what the spread is. The range is the top and the bottom score. And that's a useful statistic, but only when it's combined with other statistics. And you'll find that in a lot of cases. Range in itself, it shows a big spread, but all you have to have is one extreme score, that real smart kid in the class who got the 90 when everybody else got the 64. Okay? And you have a 64 to 90 range. Most of the class got a D on the test, but the range is that big wide number. But when you combine that with like the median, the middle score, then all of a sudden you have an idea. And you just got it with the mode, the most frequent score, then you're getting a better idea of how this class performed. But in and of itself, getting back to variance, the variance measures how the data differs from the mean. Okay. Now, unlike range, that only looks at extremes, the variance looks at all the data points and then determines their distribution. Okay. It's also sometimes referred to as the mean of the squared deviations when you're applying it to only one variable. Okay, so if we're talking about variance, we're talking how an individual score goes away from the mean. That leads us to standard deviation. Now, what is standard deviation? Anybody? Basically, standard deviation is the square root of variance. Okay, basically, standard deviation describes the variance in performance that exists within a group. Alrighty, and along with mean, reveals a great deal about the similarity and differences between two groups. Alrighty, because what would happen, you'd have the mean of the average of the two groups. You could see maybe one group's mean was higher than the other, but then you'd also have the standard deviation, which shows what the entire number of people within one group, how they separated, how their scores tend to be different from that mean. So say both groups had a mean of 85, but one had a standard deviation of 2 and one had a standard deviation of 3. With a standard deviation of 3 would tell you there was a wider spread of scores away from the mean. Okay, whereas 2, they were a little closer to that average. Alrighty, that's all standard deviation is. And if you'll remember, I don't think I put a thing up here. Okay, of the bell curve, it showed how the breakdowns of the different standard deviations, the first standard deviation, the second and third, and how it accounted for certain aspects of the population. Now, I don't know if you have the Handy Stats book, but he gives a really good explanation and a really good process for figuring out standard deviation. And what I did earlier this evening, just before class started, in the announcements in the 5610 website class pages, if you go to the announcements, I sent out a little worksheet that goes step by step through what we're going to do now. So you can use that, and if you ever have to figure out standard deviations, you can use that worksheet to help you out. I don't expect standard deviations is something, if you work with them all the time, you'll remember this formula. If you don't work with it all the time, you'll use my worksheet or something like it, or go to the Handy Stats book. It's not that complicated, but again, it is a little convoluted. And if you don't use it all the time, I'm not expecting you to memorize it for this course, for any upcoming quiz or anything else. So anyway, when you start off with your standard deviation, the first thing you do is you take all your scores. You take all your values, whatever you want to call them, and you line them up. Okay, so here you have different salespeople selling cars and how many cars they sold, and so this is what it's called your raw scores or your raw data. Okay, so first of all, what you want to do is you want to sum all the raw scores, and here you'll see all those being summed up, and then you'll take those. You'll count the number of individuals. In this case, there's 7, and then you'll divide the sum of the raw scores by the number of people that you're studying. So here you have a total of 70. It's the sum of the raw scores divided by 7, and that gives you 10. Okay, so that's basically your raw score is your average of 10. So I think you're all with me still. Okay, now there's the follow-up of that, explaining what's going on. Okay, next thing you want to do is figure out the deviation to the mean. And here what you'll do is you'll take that average, of 10 and subtract it from all the scores. And this will give you what are called deviation units. Okay, you can see Ann, Beth, and Carl, they got -3, -2, -1. They need to pick up their sales game a little bit. Meanwhile, Irma, Fran, and Greg, they're doing pretty good. They're doing better than average. Dean, he's right there at average. Now, these deviation units are nice, but as you can see, when you try to add them all up, they'll add up to 0 because you have -3, +3, etc. Now, admittedly, this example is very simplistic. I'm not going to say never, but very rarely will you get numbers that match up like this. Okay, so that for the sake of explaining things, we're keeping this simple, but don't expect the stuff in the real world to be this simple. But again, for the sake of example, we're going with simplicity here. Okay, so that takes care of step 5. Basically, you're subtracting the mean from each raw score to compute the deviations or variations from the mean for each person. And this allows you to describe how much each raw score deviates or varies from that average. Okay, so basically you're comparing each raw score to the mean. Moving right along. Maybe I'll move on. Let me. There we go. Next is steps 7 through 9. Okay, you're going to, step 6. We skipped a step. What do we? There we go. Step 6. Now, you have these minus, negative, and positive numbers, and if you try to add them together, you get 0. Now, statisticians have a problem with 0 because 0 you can't do anything and it doesn't measure anything. In some cases, it means the total absence of anything. In other cases, it just means something isn't measured. So in order to give them something to work with, they square those deviation units. Now, when you square a number, a negative number, you get a positive number. So now you have these deviation units being converted to square deviation units. And as you can see here in this right section, they're all positive. Now we can do something with this stuff. So basically it said you square each deviation score to get rid of the negative numbers. And that keeps the deviation information all positive. And squaring the deviations converts them to what are called square deviation units. Moving up to steps 7 through 9. Okay, here, and next thing you want to do is take the sum of the square deviations. And this is often referred to as the sum of squares. Okay, and you see that the sum of those squared deviation units equals 28. Then again, you go back and count the number of individuals. That hasn't changed. You still have 7. Then you divide the sum of the squared deviations by the number of individuals to compute the mean, what's called the mean of squared deviations. Okay, this is the average of your squared deviations, and here it equals 4. Now this is called the mean square, or what we want to refer to as variance. Okay, this is your variance. This is showing how far away from the mean your group is going. Now, going the big final step here, going to standard deviation. Remember I said standard deviation is basically the square root of the variance? Well, if your variance is 4, guess what your standard deviation is? It's 2. And these are the 10 steps. And said if you want to use the worksheet, if you can commit these to memory and you use them a lot, you'll have this memorized in no time. Depends on what kind of research you're doing and how often you do it. But anyway, standard deviation sounds like a big hairy deal to figure out, and it doesn't necessarily have to be. Okay? Any questions on figuring out standard deviation? All right, then moving right along. Okay, so we have all this information. We have means and modes and frequencies and standard deviations and values and variations. And, who cares? What do we do with all this junk? Anybody?
What do you mean, what do we do with all of it?
Just exactly that. Let me go ahead. Maybe you're probably thinking of something specific, and I'm thinking of something more general.
You
Statisticians.
mean just like analyzing it, or?
Yeah. Statisticians like to analyze stuff. And sometimes you look at it and you say, well, what does that mean? And there's no, in and of itself, there might not be any real value. Like, okay, for a variation, okay, how different someone's outcome is from the mean, you can understand, okay, they're above average, they're below average. That has some meaning, but some of these calculations you'll do along the way, and if you keep on going to statistics classes, you'll be looking at this stuff and going, who really cares? What does this really tell me? Well, what statisticians try to do, or like to do, is they like to find relationships. They like to find differences. They like to find proximities. They like to be able to compare, one group to another group, one person to another person, the treatment to the control. They like to compare things and see what their relationship is, what their difference is, or what their similarities are. And the more of these different little statistical tools they can throw at it, the more they can say, okay, this is different here. Now, depending on what you're studying and what you're trying to prove, some of these things will prove to be very interesting and very helpful to your argument. Yes, this proves that these are different. Other things will not maybe be of any significance to you. And you won't include them in your journal article and stuff. But basically, what all this stuff does is it allows us to understand performances and conditions. Now, do you understand the difference between performances and conditions? Everybody? Okay, let me back up here for just a second. Okay, here we have all the salespeople's the sales totals here. Ann sold 7, Beth 8, and so on. Okay, that's performance. Okay, Ann sold 7 cars. That's how she performed that week. And Beth sold 8 cars. Emma sold 11 cars. Okay, that's performance. Now, if you said when Ann was born, she weighed 8 pounds, Ann didn't have, Ann wasn't bulking up in the womb and lifting weights to get up to 8 pounds. That was the way Ann was born. That's a condition, okay? That's something Ann had no control over. So you have performance, which is something you can control, and condition, which is something that just occurs out of your control. And that's the difference. But anyway, all these different statistics will look at all of these, whether it's a performance or a condition, and allows us to compare these performances and conditions between groups in a variety of different ways. As I said, sometimes this stuff will support your arguments or what you're trying to do, and sometimes it won't. Say you had the mode, the median score, the middle, excuse me, yeah, the median score, the middle score, everything was either below it or above it. If you were to try to compare two groups, well, maybe that median score in itself wouldn't tell you a whole lot. But if you also took the mean, the average score, you said, okay, the median, the score, say the median was 80, but the average was 85, that would tell you that this group maybe did a lot better than the other group that had a median of 80, but a mean of 81. That's these different statistics you will use at different times. And you have to just think, does this apply to what I'm doing? Does this apply to what I need? Does this apply to what I'm trying to prove? I said, statistics are looking for lots of different ways to compare things. And the more they can compare, the more different tools they have, the happier they are. In some cases, maybe that comparison is part of another step, like we just went through the 10 steps for developing your standard deviation. I'm sure somewhere someone could take some of those intermediate steps and use that information to prove there's a difference. For us, maybe not. But again, basically it just allows us to compare conditions and performances between groups in a variety of different ways. One of the main benefits of statistics is that they allow us to closely establish relationships, which is something we talked about earlier on. Identify differences, which is what we're doing here, and also to gauge the strength and range of individual and group performances and conditions. Okay. Now, in the book, he gives a weird example, and I don't really like the way he set it up because he uses different groups, and you could just as easily use the same group. But anyway, I'll stay with it just so not make things even more confusing. You have four types of definition. Going out. Okay. Anyway, in one situation, you'll have both groups, the mean and the variance are the same. Okay. Another possible outcome is that one group's mean is less, but their variance is the same. Okay. Means their average score is less, but the deviations from the mean are the same for both groups. Next, you'll get a situation where the mean, the average score for both groups is the same, but the variance is less for the second group, or for the first group, excuse me. And I keep on missing my deal here. And finally, you get a situation where the first group, the mean and the variance are less. Something to keep in mind, this is probably something that'll become obvious when you look at your results, when you're comparing results. But these are the four possible outcomes. And I think somewhere in the future there might be a test that asks this question, which is why I'm including it here. So anyway, these are your four possible outcomes. Both mean and variance are the same. The first group has a smaller mean, but equal variance. Or the groups have equal mean, but the first group has smaller variance. And then finally, the first group has smaller variance and smaller mean. Moving along here. That's whenever I hit some of these little control boxes to control something for the class, I can't move my slide. Okay, degrees of freedom. And why do we use n-1? Anybody familiar with this answer or want to make a stab at it?
I think it was to make the let's see, the standard deviation more narrow, just to avoid randomness, like something like that.
You sort of got it, but you're going in the wrong direction. Actually, they're making it a little wider. They're erring on the side of inclusion. Here's the gobbledygook definition, and don't even try to commit to memory. I don't even know if I want you to try to understand it the way it is. Basically, you have some independent values that are used to compute a measure, as they call it, minus the number of restrictions. Now, when you're dealing solely with your subjects, with your population, or not your population, excuse me, your subject in the study, you don't have any type of restrictions. Okay. It's where you run into a restriction is when you are taking the findings from your subject, this small little group of people, and trying to transfer that, trying to relate that to the general population. Because again, when you're taking what you found out in your study, you might be 100% right in reporting what you found. But when you try to say, okay, now we're going to try to take this and apply it to the general population, then you can only call it an estimate. You can say, based on our study, we think this is what's happening in the general population. And because it's only an estimate of what the population is, you want to sort of goof a little. You want to fudge a little. Okay, in and of itself, when you do research, your findings are unbiased. There's nothing affecting it. Okay, you have X number of subjects, you have X number of scores. All that is there's no interpretation. You can take, like we just did, you had the total of 70, and you had 7 people working it, so their average was 7. But what you want to do when you're transferring this to the larger population, all of a sudden you're adding a little variation to it in this estimate. So in order to, again, they want to err on the side of inclusion. And so when they do n-1, that makes your results just a little bit larger, not smaller, a little bit larger. And so it automatically inflates the standard deviation, makes it a little bit bigger, because they'd rather include someone in that group than exclude them. And this is kind of strange way of explaining it, and I hope you understand. You want to be sure you capture as many people as possible within your statistic, and so to do that, they do that n-1, which makes the result a little bit larger. Does that make sense? Or have I just totally put everybody to sleep?
Yes, that makes sense.
It
Okay.
does, yeah.
Okay, good. Again, just so you understand why people are doing what. Oh, quick review again. Okay, bell-shaped curves and skews and stuff like that there. Here we see, and again, things are not always, well, you might somebody get this distribution B, the no skewness here, the equal distribution, the bell-shaped curve. You might get that here and there in your studies. And you might get stuff that's similar to this, whether the curves are exactly like, distribution A or C. Hard to say. Anyway, going through these, okay, you have distribution A, which is positively skewed. And what is happening here is that the median, remember that's your centermost score, is less than the mean. Okay, so your centermost score, meaning there's equal number of scores above and below that median, okay, that might be, say, 80. But your mean is 85. So what happens, you have all these scores below the mean, that's pulling this curve into the negative direction. So you have, say, your mean, I don't see if you can see my cursor, say your mean, your average score is over here, okay? So maybe you have a bunch of people who, okay, say your mean is 85, and it's just to the right of the top of the curve. And you have a bunch of people at, say, looks like the way it drops off, say it goes down, it's 85 here, and there's 84, 83, 82, and then a bunch of people say down, somebody at 81. Meanwhile, you have one or two people ranging out here to the right with a lot higher scores. So that just brings this skew, this curve down to the high scores. So you have a lot of people here, but because you have a few high scores, that makes your average, your mean, higher than the median, the middle score. So it drags it to the right. Likewise, you can have that distribution C, which is called negatively skewed. There, your mean, your average, is less than your median, meaning a lot of people got low scores, but people got low scores, but you had your median was at the middle of the scores, and you had a bunch of low scores, so that dragged this tail down here. Here is where your mean, your average score, is less than your median. The higher scores pull the median above the mean. Does that make sense? It sounds almost completely opposite of what you think it would be. Then you have where your mean and your median are the same, and that's this bell-shaped curve here, this distribution B. Okay? Any questions?
No.
Oops, sorry.
I just had a question actually from previous.
Oh.
The audio broke up before this.
Okay.
Before -1, the audio broke up, and you had mentioned that there might be a question about it.
Yeah.
In the quiz.
There might be.
I think it was before this slide, the one with you had the comparisons.
Oh, there you go.
Yes.
All right.
And
yeah. These are the four possible outcomes when comparing a performance. Again, the first group and the second group, the mean and the variance are the standard deviation are the same. Okay. Another way your performance could show up is your first group is less than your second group as far as the mean, the average score, but their variance is the same. The other way it could go would flip-flop that. Your mean, your average score is the same, but your variance, your standard deviation, is different. And finally, I'm talking variance. And finally, you have where your score for the first group, your mean score, your average score is less than the mean average score for the second group, and your variation is also less within the group A than it is D. Okay, again, here your average score is the same, your variation is the same, your variance. Second is the mean of the two groups, the first group is less, your variation is the same. Third, the mean, the average score is the same, your variation is different. And finally, your mean is less in the first group than the second, and your variation is less in the first group than the second. Okay?
Okay, thank you.
You're welcome. Let me go back up here where we're. Okay, we did the quick reviews. Any questions on skewness? Again, it's called positively skewed because this line goes off in the positive direction. That means you had a lot of low scores pulling the median down below the mean. Then you have the negative skew, which basically you have the skew line going here, and then the negative skew, you have the higher scores pulling the median above the mean. It sounds reverse of what it should be, you'd think, but they're referring to this tail, the direction it goes rather than the curve. And then, of course, you have your no skewness, the symmetrical distribution of that distribution B, which means your mean and your median are the same. Oh, type 1 and type 2 errors, our old friends. Anybody want to take a stab at the type 1 error? What that is?
I always get these confused.
That's why I'm going over them. I figure if we talk about them enough,
Me too.
we'll remember what they are. Because, again, it's one of those things, you use it, you lose it, and so we're trying to use it.
I know one is like you say that the null hypothesis is correct, but it actually is not.
Okay. And which one is that?
That's a type 1. Is it type 1?
Buzzer sound. Yeah. Okay.
I get them backwards all the time.
Well, and I think a lot of people do. Again, it's one of those things. If you don't use it, you lose it. And I've lost lost it a lot. Anyway, one simple way to remember it is remember what the type 1 error is. It's the false rejection of a true null hypothesis. Because the type 2 error has to be the exact opposite. So if you can remember just the one, the other one you can stop and think and figure it out. So again, the type 1 error is when you falsely reject a true null hypothesis. The true null hypothesis means, based on your findings, there was no significant difference between the treatment and the control. And that was the case of your findings, but you reject them. Okay, so the false rejection of the true null hypothesis, false rejection, that's type 1 error. Okay, type 2 error, therefore, has to be the opposite. Failure to reject the false null hypothesis. The null hypothesis isn't true. There was a difference, okay, but you failed to reject that. So again, false rejection of the true null hypothesis is 1. Failure to reject the false null hypothesis is 2.
And null hypothesis means that there is no significant difference.
Correct.
Okay.
Yeah, for some reason they decided they were always going to state, even though they were hoping there would be a difference in the treatment and stuff, the null hypothesis, they always stated in terms of the null hypothesis, there's no significant difference.
Okay, thank you.
Okay, things to think about. If you haven't studied or read up on these already, you might want to do them in the next coming days. Frequency. You want to think about frequency graphs, frequency distribution, relative and cumulative frequency. What are they? Again, we've talked about a lot of this tonight, the means, the medians, and the skewness. What is a normal distribution? Qualitative research methods. And what is a true quantitative experiment? Okay, let me see here what we got. Okay, upcoming dates of importance. Assignment 3 is due July 11th, which is 2 days from now, Wednesday. On Thursday through Saturday, quiz 3 will be open for you. On July 18th, assignment 4A is due. Okay, that's going to be next Wednesday of next week. And the final paper is not due, assignment 4B is not due till August 8th, the same day quiz 4 will be due. Okay, so these are the upcoming dates. Now, we've pretty much gone over assignment 4A. and there's not a whole lot going on. Quiz 4B, or excuse me, Quiz 4, by the way, is pretty much like a comprehensive quiz. It goes over the stuff that's on the other 3 quizzes. So if you want to study for Quiz 4, look at quizzes 1, 2, and 3, and you'll be ready for Quiz 4. I don't recall seeing anything new on Quiz 4 that hasn't already been covered in the previous modules and quizzes. There's no new information in Module 4 other than to get your final assignments. So I was wondering, seeing how we don't have any real new information, and we've kind of covered the old information, the old quizzes, I can't really see having a meeting every Monday for the next, couple Mondays. Certainly not next week. I think you'll be busy enough finishing up, because assignment 4A is fairly simple. And so that shouldn't be I don't think anybody needs any problems. There won't be a quiz next week, so there's no sense in trying to prep for that, because there's nothing to prep for. So I was wondering, over those not next week, but the weeks after, the July 23rd, 30th, and August 6th, would you want to have a meeting during one of those Mondays? I don't think we need to have all 3. I don't even think we need to have all 2. I didn't know whether waiting till August 6th would be too late. Or July 23rd too early, or what do you all think? You 3 get to decide the fate of the class. So if they all,
I would think August 6th would be too late.
I would think so too, but I wanted to offer it because some people won't start the final paper until August 5th. So.
Right.
That is true. Maybe before August 6th, what would be the Monday before that?
That would be July 30th.
Yeah, maybe July 30, we can do like a review. Maybe I might have some questions about my paper.
That's what I'm thinking. Because if you wait till August 6th to ask questions about your paper and say, well, you are so off track, you are in another universe, and you're sort of out, up the creek by then. We're by July 30th, right. And I think when you folks are doing proposals, I apologize, Lucy, for replying to your proposal in the public forum, but I figured other people would have the same idea, and I didn't. You had a really good idea. I just wanted to make sure. One of the things you'll see in writing, and if you ever go for a PhD in your dissertation studies, your major professors are always going to tell you to narrow the scope. Don't take on too much. You say, just take a little bit. So that's why I suggested you drop the learning styles and just focus on the multiple intelligences. And,
okay.
So I think probably people have enough of an idea on 4A just by my comments to them in the forum. And assignment 4B, I think, again, you're following from 4A, you're just fleshing out that idea. And hopefully you're getting an idea of what I'm looking for. Whereas, July 30th would still give you, a week and a half to, because you'll have till the 8th to turn it in. That would still give you a week and a half to correct any major misconceptions or whatever you had going. So shall we say July 30th?
Yes, I think that would be great.
Any objections? Okay, so I think that is July 30th. Now I'll change this last slide before I post it, so that I won't be. Oh yes, I will. I will. No, I won't. I'll send out the PowerPoint. I'll send out the notes, because this is all being recorded and I can't change the stuff within the recording. Okay. And oops, I keep on. Any questions?
No, is the quiz 3, are you going to have any kind of calculations?
Yes. Yes, there are. But I think it's something you should be able to do with all the information and resources you've been given.
Okay.
All righty. So.
Okay, thank you.
You're welcome. So, so the quiz will be open on Thursday until Saturday. There will be some calculations, but I think you have everything you need in order to figure stuff out. And if not, you look back at this video, and I'm sure the answers to all the quiz questions, or at least good hints to the answers, are all inside this video. But hopefully, your readings and everything we've gone through already should prepare you for that. So I don't think you'll have any problems. And I will wait till after assignment 3 has been posted before I do that extra credit assignment. And that's pretty much all I have to say, unless folks have questions.
No, thank you very much.
All right. Well, thanks for coming. Hi, Omar. I didn't know. I just looked down and saw you were here. I don't know whether you just got in or you've been here for a while. I just started rambling and talking and I didn't pay attention to the attendees. Anyway, thank you all for coming tonight. Look forward to reading your next papers and your final papers, of course. It's been a good meeting, and I'll
are you gonna have this recording available tomorrow or
yeah.
when?
Yeah, last week it transposed pretty quickly, and I think I even put it on that night. But I'm a little tired tonight, so I might set it to transpose, and I'll load it up in the morning at the latest.
Okay, great. Thank you.
All right. Well, everybody, it's been a good evening. Thanks for coming. I hope you got something out of this. And again, you know where to find me if you have questions. And until July 30th, take care, and I will talk to you soon.
Thank
All right,
you.
thank you so much. Good night, y'all.
Good night, y'all.
Good night.
Bye-bye.